Okay, 3.6, number, which one? 3? Okay, that means round off error sincere, so you did it right, you just rounded incorrectly, and you rounded too much. That's one thing, and this isn't a huge deal, but it's gonna cost you points if you round off when you don't need to. So the problem sincere is talking about is on the homework, 3.6, number 3. So we're gonna use this formula right here because it says compounded monthly. It says the account is now worth this much money. We wanna know what we invested at an interest rate of 3.5% compounded monthly. And we did it 18 years ago. So the question is, your parents went down and put a chunk of money in the bank 18 years ago when you were born. It's now worth this much. So we're just gonna figure out what we originally invested to make that happen. Now, first of all, what's 12 times 18? 216. Can I type this in on my calculator? I absolutely can. So, I'm gonna type 1, oops, I need parentheses 1 plus 0.035 divided by 12, raised to the 216. So I have a number now for this. I have 1.8758, right? That's the number I have. There is zero reason that I would write that number down. There it is, okay? I'm not rounding it off. I'm not even writing it down on my paper. I mean, I sorted them, but not for any purposes at all except for you to see it. This is P times something equals this. How do I figure out what P is? What do I need to do? Just basic solving an equation. What do I need to do? Divide. I need to divide by that number, right? So I type 3, 4, 5, 6, 7 divided by second answer. It will just pull that number right down here. No round off at all. So P is 18,426 and 99 cents. That's the answer.
Where'd you find the answer book?
Right where it's always been, right above your negative sign. We've used it before.
Oh, okay.
Anytime I need a previous number, that like the thing I just typed in, I can just second answer it and it pops it right up. All right? Now, tomorrow or Monday when you take your test, if you round this off, say, okay, that equals 1.875, and then you do this divided by 1.875, you're gonna get something close to this, right? But it isn't gonna be exact. You're gonna miss 1/8 of a point. All right, I'm taking off 1/8 if you round off when you don't need to. All right, with our calculators, we don't need to round off very often. We can almost always just use our answer button. All right, anything else you think we need to talk about? Remember, we're not focusing on the exam. That's for another day. Right now, we're focused on finishing this quarter strong. Your quarter grade is 40% of your semester grade, so we want it to be good. Okay, so who else? Some of you need a really good grade. Okay, we've done 3 practice tests. What your silence is telling me is, number 1, you don't give a crap about doing well because you haven't spent any time reviewing it. Number 2, you're a good ace because you know everything. Now, are either one of those things true? Do you care? Then why are you sitting there staring at me? Brennan?
There's letter H on the practice test.
Which number does it go with?
It's under number 4.
4H. All right, so which practice test are you looking at?
1.
All right, practice test 1,
Probably like
4H. Yes, a problem like that. Well, let's go ahead and do that one because we haven't done it in a long time. And then we'll do another one similar. to it. So this is on the no calculator part of the test. So if I were walking down the hall with my calculator and I found this problem, I would probably log both sides, because isn't that what I do when my variable is an exponent? Yep. But if I don't have a calculator, that is not a good strategy, because I don't have a log button in my brain. So there's got to be something else I can do with this problem. So we look at the two numbers, and 27 and 9 are not random, right? It's not like 17 and 11 or something like that. What do we know about 27 and 9? They're both powers of 3. So we'll change the 27 into 3 cubed, and we'll change the 9 into 3 squared. If you don't have a calculator, this is what you have to do. And usually we change them into 3s or 2s, something small, because again, you don't have a calculator. So once you do that, then the exponents are equal. So 3x equals 2 and x equals 2/3. Sometimes we've seen problems like that that have an extra number in the front. So something like maybe 2 times 5 to the x plus 3 equals 25 to the x minus 1, something like that. No, can't do that. Equals 50. What do we do first if we have this? We did not have it in this problem, but if we have an extra number out here, what do we do? Divide by 2. So 5 to the x plus 3 equals 25. And what do we know about 25?
5 squared.
5 squared. So 5 to the x plus 3 equals 5 squared. So x plus 3 equals 2 and x equals -1. If you do not have a calculator and you are trying to find an exponent, you have got to get a common base. These two numbers have to match. Sometimes we have to change them both. Sometimes we only have to change one of them. But you always have to make them match. Okay? All right. What other kind of problem do we need a little bit of extra practice with? Ruby?
Practice test 1, 3F.
3F. So a big simplification exponent problem. So let's go ahead and use 3F. We'll do another one. Okay, now, it really doesn't matter, but I always think it's easier, me personally, I think it's easier if you simplify what's in here first. I know eventually I've got to deal with the exponent, but there's a lot going on there. It's probably going to be easier for me just to clean that up. So 2 and 3, nothing happens. Can't simplify 2 and 3. But what about my x's? What happens with my x's? I got 3 on top and 4 on the bottom. So that's going to leave me with an extra 1 on the bottom, because the bottom has 4. Now, what about this negative here? What do I do with negative exponents? Drop them down. If they're on the top, drop them down. So there's already 1 down here. Now these are going to come down. So now what have I got on the bottom? y5, y to the 5th. So now that's all cleaned up. Are you good to that point? Now I gotta square everything. So 2 squared is 4, 3 squared is 9, x squared is x squared, And what do I do with these exponents here?
Times.
Times, so y to the 10. Alright, so let's do one more like that. Oh, let's make it really big. Okay? Now, again, with a problem like this, you know, one of these giant, simplify things, I would just forget that for a second and focus all my energy right here. So if I just forget that exponent, just look in the parentheses, I got a 9 and a 16. 9 and 16 do not reduce. It's not like 8 and 16. That would make 1/2. This does not reduce. What happens here? They actually trade places. So I'm gonna have an x squared on the top and an x to the 4th on the bottom. Well, that's actually gonna be, if I just now clean that up, that's gonna be an x squared on the bottom. And then what about my y's? I've got 10 on the top and 16 on the bottom. So 6 on the bottom. Would everybody agree that that is that stuff simplified? So now I have this to the negative 1/2. All right, one step at a time. What does that negative do? Turns the fraction. So I'm gonna have 16x squared y6 over 9. Everybody okay with that? Flip the fraction because of the negative. Now, everything goes to the 1/2 power? Well, wait, what does it mean when we say 16 to the 1/2 power exactly? Geo's back there going like this. 1/2 power is square root. Fractional exponents are radicals. So 16 to the 1/2 is 4. And 9 to the 1/2 is 3. Now, again, what do I do with the exponents? When I have 2 of them like this, I multiply. So that's going to be 2 times 1/2 is 1, and 6 times 1/2 is 3. Okay? All right, what else from the practice test? Or homework, or quiz, anything that I've turned back ever in this unit. So we've been on this unit for a long time. Gio,
Will you do another one of those?
another one of these?
Yeah.
Okay, yeah, this is one question on the test though, so I don't want to use up our whole review time on this. This is one question, there's a whole lot of other questions. Take a look at this one. All right, let's clean up what's inside here. So 8 and 27 don't reduce. How about this? What's happening here with the x's? What's going on there? The one on the bottom is going to the top. So there's 4 of them up there. Up come 5 more, which will give me a total of 9 on the top. This is just the opposite. These are coming down. So I'll have y to the 12th on the bottom. Okay, s to the 1/3. I know that I'm going to multiply my exponents. So my x is going to be x to the 3rd, 9 times 1/3, a third of 9. And a third of 12, 12 times a third will be y to the 4th, I know that. What do I do with the 8? Cube root it, so So 8 to the 1/3 means the cube root of 8, and the cube root of 8 is 2. Same thing with 27, cube root of 27 is 3. So there would be the final answer of the problem. Fractional exponents are radicals. Negative exponents are flip. Alright, what else? What other kind of problem? Yep, which formula do you want to practice?
Use a part with missing
Okay, so let's say we have, I'm not gonna write out like in complete sentences and everything, but let's say we have 273 bacteria, and they're gonna grow into, so I start with that many, but they're gonna grow into 8,000 bacteria. And it's gonna take them 12 hours to do that. So the question is, what's the growth constant? That's the rate. That's what we call the rate, the growth constant. Okay, since it's bacteria, we know it's PERT. We know we're ending with 8,000, starting with 273. We don't know the rate, but we know the time is 12. So what's step 1? This definitely is a calculator question. What's step 1? Divide. So we have 8,000 over 273. We are not going to round that off because we already got a lecture about round off error. We don't want it. Just going to leave it as a fraction right now. Now, look where that variable is. It's an exponent. That means I either need to get a common base or I need to use logarithms. If I have my calculator, I'm going to use logarithms, right? There's no common base there anyway, but I'm going to ln both sides. Now, why did I choose ln, that type of logarithm? Because there's an e, and as soon as I put that in, that goes away. So 12r equals ln 8,000 over 273. And then to get r by itself, I need to divide by 12. So ln 8,000 divided by 273, close parentheses, divided by 12. That growth constant is 0.2815. Now, I noticed, I think I overlooked it yesterday, but I noticed later in the day that for the calculator section on practice test 3, I was having to round to the nearest thousandth. On a previous one, we were rounding to the nearest 10,000. So we gotta pay attention to that, and I did not. If I am rounding this to the, okay, here was the whole number. There's more after that, but I don't need it. So if I'm rounding to the 10,000, that would be right here, right? So since that's a 7, it would make this a 5. So to the 10,000th, it's 0.2815, if that's the direction. If it's the 1,000th, I would be rounding right here, right? 1,000, well, that's a 4, so I'm gonna leave it as 0.281. No big, I mean, not a huge deal there, you just gotta pay attention to the directions, and I did not yesterday. I'm pretty sure I did not. Okay, so just whatever the directions say, that's what you're doing. Okay, got that? All right, now, what if we have one of these and we're looking for the rate here? For this, it would be the interest rate. So what if we started with $250, it grew into $789 in 15 years, and it was compounded what's the interest rate? Alright, so here's the problem. You know that you deposited $250. You left it in there for 15 years, and it grew into $789. Your bank compounds the interest quarterly. Your job is to figure out the interest rate. Okay? So since it's compounded quarterly, it'll be that formula. Right? So here we go. 789 equals 250. 1 plus R, that's my unknown, compounded quarterly for 15 years. Will I be using logarithms on this one? Will I be logging or ln'ing on this one? No, because I only do it when I'm looking for this. I know that's 60. What's step 1? Divide by 250. So we have 789 over 250 equals 1 plus R over 4, the 60th. This is one of those strange ones where I really need to take advantage of a particular button on my calculator. I am solving for this guy. So eventually I want to have R equals, that's what I need. But he's in this stupid parentheses getting raised to the 60th power. So what do I need to do? I need to get rid of the 60. So I'm gonna square root both sides, only it's not square rooting, it's 60th rooting. Because as soon as I do that, then there's no more parentheses. They're gone. That cancels. So this is a number, I know how to find it on my calculator. To get R by itself, I'll want to take that number and do what? Minus 1. And then what? Times by 4. My calculator will do all that for me. So, who remembers how to do that on my calculator? I gotta do this first. Who remembers how to do that? 60. Math. 5. 789 divided by 250 equals, whoops. Oh, yeah. 60. I got an error because I forgot to put the first parentheses. Parentheses, 789 divided by 250. So when I put it in my calculator, you guys may not need to, but I need to have this in parentheses in my calculator. So this number right here is 1.019, I'm not rounding it off. I'm just putting it there for my reference. My job is to solve for R. So I'll just take that number on my calculator and minus 1. So now I have 0.019 of that equals R over 4 times by 4. And that interest rate, my calculator says 0.077358. What interest rate would that be? 7.7%? Everybody agree with that? Since I need an interest rate, I'll answer it as a percent. Okay? All right, what else?
For
4. Are we still on the first practice test?
I believe so. It's like,
Okay.
yeah, it's
Alright,
one
so
of,
4
and 3 logs.
Yep. So now this is a no calculator problem. And we are solving an equation that has a whole bunch of logs in it. talking about it, you can't have two logs on the same side. It's okay to have this one, there's nothing wrong with having one logarithm, that's fine, but you can't have both of these over here. So we have to put it together, so we only have one. And when we put it together, when you're putting them together, it's going to go together as either a multiplication or a division, and this one will be a division, and it's first over second. Okay? Now, the minute you make that happen, the minute you get these two combined into one, then what can we do, since we have one on both sides? Then we can just wave them out and solve the resulting equation, which would be this. Now, this equation's a little harder than some of them we've encountered. How would I solve that equation? What would I need to do to get started? Multiply by x. And then I got an x squared now, which is fine. But what does that mean now that I have an x squared? I gotta get it set equal to 0. So I'm going to minus the 3x, add the 2. So my equation looks like that. Then I need to either use the quadratic formula, if I want to, that's fine, or I need to factor it. And that one does factor pretty easily. So x minus 2 and 1, 1 and 2. And that gives me my answers then. So x minus 2 equals 0, x minus 1 equals 0, so x equals 2 or x equals 1. Now, that is different than if the equation had looked like this. It starts the same way. I still have to put these two together, so I'm going to put it together the same way. It's the same numbers and everything, put it together the same way. But now it's different. What do I need to do now? Loop that. I gotta loop that. When you have a logarithm equal to a number, you're gonna loop it. So 6 to the first equals 3x minus 2 over x. How do you solve that? Multiply by x. So 6x equals 3x minus 2. Subtract the 3x. And divide. Now, I made this problem up, so of course it came out badly. Everybody okay so far? X equals negative 2/3. That's actually an extraneous root, because if I put negative 2/3 right here for x, if I checked my answer, I'd have to take the log of a negative, and that is not allowed. So that's actually an extraneous. Everybody can solve it though? Okay with that? Okay.
Well, when putting the answer, do you want us to put extraneous solution or do you just put no
Empty
solution?
set. Yeah, empty set. Okay? All right, what else? Who else found one? These are good questions. These are good things to be reviewing. Who else has something?
Exponential function.
Writing one, you mean?
Yeah.
So, she wants to write an equation of an exponential function given a couple of points. So let's take the point 0, 7, and I gotta plan this or it will be a disaster. And 356. Okay, so we're gonna write write the equation of the exponential function given these 2 points. So please start by writing down what does an exponential function look like. Y equals a times b to the x. That's an exponential. Your job is to find a and b. Do we really need to find a? No, what do we know about a? It's that right there. That is always gonna be a. So 7e to the x. Now what? Plug in for x and y. So 56 equals 7b cubed. And then, this is no calculator, so yeah, we're gonna divide by 7. So 8 equals b cubed, which means b equals 2 cubed, 2 times 2 times 2. Then don't forget, write the answer. So y equals 7 times 2 to the x. That's your answer, the equation. What if we had this equation? And I said growth or decay. Decay, because this number right here is less than 1, so this is decay. And then I said, what's the percent growth or decay? Is it 90.5? No, it's not. The percent growth or decay is the amount that you're different from 1. So how much less than 1 is this? Well, it would be 100% minus 90.5%, right? That's how different it is. Which is what? 9.5. So this would be 9.5% decay. How much you're more than 1, that's your growth. How much you're less than 1, that's your decay. And what do we call the 13? Initial value. Yep, that's your initial value. How about this? What if we had something like 2 log base 8 of x minus plus 3 log base 8 of y minus log base 8 of z? What if we had to put that together into a single logarithm? That's what the directions say. Write as a single logarithm. So in other words, you're going to have log base 8 of something. A single logarithm. What's going to go in that parentheses there? Brennan?
Squared y to the third, and then z under both of those to just
That's it. It's to the first, right? Because there's a number out there. So, everybody remembers that that plus goes together as a multiply. The minus goes together as a divide. And these numbers hanging out in front are exponents. So when there's 2 questions, you know, because you've done the practice test. The other one says it starts with something like that. So it starts with something like log base 5 of x cubed y squared. And it says break it apart. The directions, actual directions say expand. Okay, so if you expand that, that means you're going to have a log base 5 of x and a log base 5 of y. You're gonna have one for every letter. However many letters there are, you're gonna have a logarithm for that letter. What else? I need some other stuff in there.
The exponents go for
So, this 3 is going to show up where? Out here? And the 2 is gonna show up out here, okay?
it's a plus.
And in between is a plus, because that is a times. So this is one problem that where you take a big long thing and smush it together, and then another problem where you take something like this and break it apart. Alright. Schedule says we end at 9:25, so, alright, we have a test on Monday.